Hello, welcome to the CTF special, the Zero Deus series. The people from the DefCamp CTF from yesterday should have some PTSD with it. The name is Zero Deus because nobody managed to solve it, so zero solves. I apologize for that, but let's go on with the presentation itself. So first of all, 3 things to mention. First of all, the controversial opinions are my own. And also, this presentation is rather humoristic. I have to also thank the people that made this presentation possible, Sorin and Ștefăniță, that helped me make the front end for the application and that helped me with the review of the solution and the presentation. Of course, I have to thank Andrei and Darius for putting the challenge for DCTF. And let us begin. So, who am I? I am Matei Badanoiu. I've been hacking stuff for 8.5 years, or 8.5. A professional experience of 7 years, hungry CVs in those 7 years, in VMware the most recent, Cisco ISA, and also the most relevant for today, Apache ActiveMQ, Artemis, and so on. But you probably don't know me as Matthew. You probably know me as this guy. So, hi, I'm Mal. Or for those of you that know French, je suis mal, which is a colloquialism for I don't feel well. And I have a cold today, so I don't feel well. The interesting part about me, besides the thing enumerated there, is my GitHub. I will be posting the scripts and solutions for this challenge there as well. But like any good story, it begins with a 0 day and a glass of milk. The 0 day has been presented before at DefCamp Cluj-Napoca, the Log4j-MX series, actually the Log4j-MX vulnerability, the vulnerability that never existed. Anyway, in a nutshell, if you have a Log4j application and you're exposing the mbeans via straight JMX, Jolokia, Hautio, or so on and so forth, then you're going to have a bad time because you're in the danger zone. So, with that being said, let us get to the Zero Deus challenge itself. The Zero Deus challenge was given to the Cybersecurity Olympiad, or the ROW CSC qualifiers. It had 2 parts, the black box PHP part, which you had to analyze behaviorally, and the Apache ActiveMQ part, which was white box. You got the scripts to set it up locally, and you could have investigated from there on your local computer. And the goal, as with any good CTF challenge or thing in life, is to get remote code execution. So, because I like starting from the end, let's start with the remote code execution. The public, or at least what we know, is that we need to get remote code execution. The Red Hat Artemis, the Red Hat AMQ application is a reskin of the Apache Artemis AMQ application. And the interesting public information we have is that there are 2 CVs from it. One from 2022, which allowed via Log4j to write arbitrary files, and another one more recently published last month from CV 2023 in Apache Artemis itself and Red Hat AMQ. We also have a proof of concept for these 2, which can be found at the following link. But anyway, going back to the Cluj-Napoca presentation, this is the Python script for exploiting the vulnerability. I won't go again into detail with it, but the RC idea is relatively simple. We have 2 files which we can overwrite for remote code execution. We have the broker XML, or we have the web archives which are loaded by Jetty. What would be the idea? First of all, we need to get the credentials for the application. They are default credentials. You can either crack them using a tool I posted this week, Artemis2 Hashcat, or you can just try the credentials admin. They are default credentials. They are easy credentials. It should be the first thing you do. So this would be a video of how the process should work. First of all, we look in the web directory of Artemis. We can see that we have a few vars. These are the only vars that are being deployed. So we need to overwrite one of these. We have our generate property py, which again, I won't go into detail. I will put it on my GitHub if you're interested. This Python code takes a file, whatever it is, the content of a file, and then writes it to an arbitrary location on the target system. In this case, we want to write it instead of the Artemis plugin web archive. In this case, we have generated the log4j2 properties files. And now we're going to set up a Python server in order to host the payload and then give it back to us. From here, we can go to the ActiveMQ application. We're going to change the location config location URI to our malicious server to point towards log4j2 property file. We're going to wait for the server to start. It's going to start on port 8000. we're gonna submit the configuration location URI change. It's gonna get our log4j properties file, as can be seen here. And now we need to wait a bit more for the changes to take effect. We can see the green check mark and then the logging on the upper right, you can see that it started spitting out informational details. So that means it loaded our configuration, it wrote our var instead of Artemis plugin, and now I try to show with a diff that there is no change between these two files. Also, I do a small mistake here, but we will forget about that. So the idea is we have overwritten the jar, but the changes have not yet taken effect. We will see how we can restart the application for the jars to be deployed just in a second. So yeah, I remember that I also need to use sudo because guest cannot see in home CTF. And we can see that the diff returned no response. That means there is no difference between the files. The length is the same. We know that we have written through log4j our Artemis file on the target. Now, if we go to other Artemis and beans, we can see in this 000, which is the Jetty and beans, that we have restart embedded web server, which restarts the Jetty. This destroys the current context or the vars that are deployed and tries to redeploy them again. But if you remember, we have modified the Artemis plugin to be our var. Now, we'll need to wait a bit for the server to restart. But once it restarts, we can go to the path that the var should have been deployed. In other words, /Artemis plugin. We can see that the server is still deploying, and we get this index.html with hello world. This is not the default index.html. Now, again, because Jetty does not support JSPs, we needed to precompile a servlet, which is a precompiled Java class, which the Jetty will parse. Again, no JSPs, but precompiled code works. In this case, we have our password because we're security researchers and we put passwords on our backdoors, and we can execute the ID command. So perfect. If you manage to do all this, congratulations, you have exploited CV from 2023-50780. Now, for the PHP part, this was the easy part until now. So, we have very little initial information. It's a black box, no code has been given, and we need to find the index PHP part because, of course, I allowed the index HTML to be the default Apache config, and you need to find the PHP one. If we look in the index PHP, we can see that there is a parameter called URL, and we should try fuzzing it. What are the interesting things about it? If we point it to a remote location, let's say an ngrok or something that points back to us, we can see that we have an HTTP protocol of 1.0, it will become relevant later, and we have a custom header called xrefer, which is sent from our SSRF request to any remote location we want. These are the SSF particularities I mentioned before, but let's try fuzzing it. In this case, I've tried fuzzing it with all characters from null byte to FF. In this case, we're interested in the following things. We can see in the get URI that we have something, something, something. The non-printable characters have been replaced with underscore. We can see a space that has not been encoded, and that's problematic because it destroys the HTTP format, and we'll need to find a way to bypass it later. But after double quotes, we can see we have a question mark and then nothing after it. A question mark does not come after double quotes. What comes after double quotes is hashtag. And hashtag, as you know, or as you may know, is a way to delimit the query in HTTP. There are three parts of the HTTP header. Besides the protocol, you have the username and password, the URL itself, the path of the URL, and then you have question mark for the query and hashtag for the hash. So the hash is not included in the URL, but is included in our xrefer header. We also see that our OA and OD special characters have not been encoded. That means that we can do CLRF attacks. So let's do a demonstration of this CLRF. We have included or encoded the hashtag as %23, and then we included ODOA. This is the usual CLRF in HTTP format, actually in URL encoding. And we can see the result is a custom header mal, and the rest of the message has been pushed down. That means that we can inject custom headers in this request. What can we do with this? Well, we'll need to search further. Again, these are the specifications that we need to watch out for spaces, but let's also look at the Jolokia and Jetty particularities which we exploited in the past step to get remote code execution. So Jolokia will require that you have an origin header set to 2 points localhost. It doesn't care, it's a wildcard match. It doesn't care about the protocol or what comes after it. And also we have Jetty that takes by default cookies for authentication because it requires valid authentication. But we don't know that cookie and we don't have post-based requests we can do. We only have get-based requests. So we're going to use authentication basic to inject a header which the value we know. Okay, this is how a valid header from the requests done before would look if you capture it in burp. Again, we do not know the cookie. We cannot generate the cookie because it is very random, but we can replace it with an authorization header. And again, our problem is that this message is post. We need to transform it to a get message in order to be able to use the SSRF. So, what's the idea behind it? We're going to use the SSRF to point to our port 8161, which is the port our current application was running on localhost. And we're going to use the SSRF to reach it, because it only listens on localhost. And this is the movie on how to do this. We have, actually, let's see if we can pause it a bit. Okay, so we have 2 requests here. The first request is a GET request with our path to get config text is just a random mbean that we want to try that it works. And we have our origin and authorization headers in there. If we try to copy the URL as is without the origin and authorization header, we're going to get a 403 response because, again, we're not authenticated into Jetty. So 403 forbidden. How we can bypass this? Again, we're going to replace the new lines with %away before the origin and before the authorization header. We're going to delete the new lines. And we also need to replace the hashtag with %23 because we want that hashtag to be parsed by the PHP itself, not by the Apache web server before it reaches the backend of the application. So now we do the request, and instead of 400, we get a 200. And we also get the content of the respective mbeans get config text. Okay, perfect. We have done this. Let's try it in a different mode. A more easier mode to do this would be to take our request. We're also going to point it towards ngrok in order to see the full request that is sent to the client. We're going to go to burp decoder. We're going to encode it as URL, encoding everything in it, including the new lines. And we're going to take the previous request and change the URL with our currently crafted payload. I don't know why it's skipped, but oh well. Anyway, that should work. And now if we go towards our application again, if we try it raw, we're going to get a 403 forbidden. If we try it with our headers, and again encoding it in burp, we're going to get the content of Artemis, actually the Jolokia list of all the mbeans present in Artemis. Yes, right now I'm taking the request and putting it in repeater about 3 times because we'll need to do 3 different requests for this. So yeah, we encode the request. We're going to put it in the URL. And once we hit submit or send, we're going to see that we get a 200 response and we get a whole lot of mbeans. We're not interested in most of them, but we're interested in the log4j2 mbean. More exactly the type of this mbean because it changes every time you run the application or every time you run it under a different environment. Now, using this knowledge, we're going to go to our second payload and we need to replace the type and also host. This is in order to replace the config location URI as we did in the previous step with a remote location such as HTTP, attacker server, so on and so forth. It will take a while. We're also starting an ngrok that will point to our HTTP header, HTTP server. We're going to take the location of the ngrok because this is the second information we need. And we're going to replace the configuration location URI with this HTTP. Another peculiarity of Jolokia is that slashes are considered special characters. So if you're doing a GET request with Jolokia parameters that require slashes, you also need to escape them with an exclamation mark. So yeah, you can find all this in the Jolokia manual. I'm not going to go very in-depth into it. But again, we generated our payload. We're going to put it in the URL. And if we submit it, we can see that our configuration location URI has been successfully modified to point to our HTTP header. HTTP server. We can see that a GET request has been made. And now we need to wait a bit for the server to take the property files and to actually overwrite our Artemis plugin as we did in the local example. This, again, is running on the remote server. Once that is finished, we generate our URL encoded payload for restarting the server. We're not going to get any response because the server is restarting. So it's obvious that we're not going to get any response. And now we need to use the SSRF one last time in order to point it towards host 8161, where our Java servlet is, where our malicious Java servlet is now being hosted. So in order to do this, we're going to use the following URL, this HTTP mel javax, the one we used earlier in the remote code execution example. We're going to, again, encode it. I don't think encoding is necessary here, but actually, yeah, I don't think the encoding is necessary, but I'll do it out of reflex. And we can see that we get the flag. Actually, we get the execution of the ID command. To get the flag, it's another a bit complex because we're going to do the following thing. So we know that the last two characters of our URL encoded command is ID. So we're going to replace them entirely. In order to get the flag, we're going to LSLA, and we need to encode the space twice because a particularity of the challenge. We're going to see a directory called flag. In this flag directory, if we go through it, we're going to see a few randomly generated files, which are generated every time at runtime. This prevents CTF players from just reading the files because log4j has a read primitive that allows you to read any file you have access to. And also as another safeguard, besides the fact that we have 3 randomly generated directories, which are SHA-1, and thankfully for us, after the first directory demonstration, because we have a bash shell, we can just use wildcards, so we don't need to complicate ourselves copying the whole path. So once we've done all this madness, the flag file will be chehash moded to 0. That means that nobody except the root user can read the flag. But you are the owner of the CTF. You are CTF, you are the owner of the file, you can chmod it to anything you want. So we are going to chmod it. We are also going to read the README, which gives you a hint that you can chmod the file directly and then read it. And from there you can get the flag. I'll let the rest of the presentation go on, and hopefully it's self-explanatory. So yeah, we chmod it with either 700, 600, or 400, whatever works in order to have read access to the file. Again, we're going to double encode the space. And we're not going to get any response because chmod does not return any response, but we can just cut the flag and get the flag. Again, this was the easier part of, the easier version of the CTF challenge, which was given for the OSC, the cybersecurity Olympiad. So anyway, let's do a small recap. So we had 2 parts. We had the PHP part, which we can SSRF towards the outside and use it to SSRF the 8161 port that only listens on localhost. We can do a CLRF on HTTP 1.0 that allows us only to do arbitrary header injection. We had the easy default credentials, which are admin, and we used the set location URI, config location URI, in order to point it to a remote location, overwrite either the, either the broker XML file or the var file. There's also a third solution to this, which we'll discuss shortly. And of course, to add to the confusion of this, there is no Zero Deus challenge 2, we jump straight to 3. Anyway, armed with the knowledge from Zero Deus 1, this should be easy. And again, it is simple. We just kill the Batman. I mean, get remote code execution. So the Zero Deus 3 challenge, which was given at the DefCamp CTF yesterday, is a full white box challenge. You have the Docker file with everything you need except the flag, of course. And again, we have 2 parts. We have the SSRF part, but we have no outbound connections. So you need to test it on the Docker file locally to see what happens. And you also have the PHP code. You have a CLRF in HTTP 1.1. This is not necessary, but it makes your life easier. And again, in the AMQ part, we cannot do remote code execution as we knew so far, because the wars are owned by root and are read-only. The same for the broker XML. So how do we bypass this read-only conundrum? What can we find as a new exploitation vector? So I won't go too much into this. For making our testing life easier, I just exposed a port on 4444 and used socket to forward our 8161 port that listens only on localhost. If you have a more elegant solution, then please tell me. This is how I usually test things that listen on only localhost on Docker. But yeah, this is just to make our life easier. It's not exactly mandatory. Okay, so what is the new exploit vector? Thankfully, the internet is full of people, and probably this room is full of people smarter than me. So we have from 2022, PyNerd came up with a solution to exploit Jolokia and to get remote code execution via a jar. What is the TLDR of the blog post? You can write an arbitrary jar to an arbitrary location on the local system and then trigger the remote code execution via this JVMTI load agent. Okay, so let's do a small test. Again, we're gonna write our Java agent. Again, the code will be posted on my GitHub. We're gonna create a valid jar on our local system. We're gonna use Docker in order to move the file to our container which we control for testing purposes. And then we're gonna execute, or we're gonna enter our Docker in order to see that the jar was copied in temp. From here, we're gonna enter Artemis. We're gonna see that we have no JMX plugin, and we need to modify and burp the request header for origin and for referrer in order to point towards localhost, or these plugins do not show up. We're gonna go to diagnostics commands, and we're gonna use this JVMTI load agent. We're gonna point it towards our temp jar, and we're gonna get remote code execution from that. Return code 0, and we can see in temp that we have our RC test, which was written by the CTF user. So perfect, we have our new RC vector. How do we move the jar to the server? As you can remember, okay, you can decide what commands to run by yourself. I personally like to move the flag to a web location and then curl it from there, or in this case, SSRF it from there. But you can probably use other solutions. So we have a problem. We don't have any outbound TCP towards us. In the Zero Deus 1 challenge, we have hosted a malicious HTTP server with our log4j properties, and then we pointed back towards it. Now we unfortunately cannot do that. So what can we do? We have a setconfig text, which is a function that does not require a remote connection, but it requires XML. And our jar file contains binary characters. Again, from DefCamp Cluj-Napoca, I won't get into this. XML does not accept binary characters. So everything from 0 to 8 is an invalid character, is considered a control character. Thankfully for us, the log4j properties gives us another solution, the JSON. So what does JSON see? If you give it a \U0000 or the UTF-8 encoding, it gives us a null byte. Same for character 255, \U00FF. So from here, these are valid ways to insert binary content in Jolokia. But what does XML see if you give it this? It just says it's 6 random ASCII characters that are okay. They are not control characters. They do not stop our payload in any way. So what is the conclusion? We will use setconfig text in order to write, actually to load our XML configuration. And from there, we're going to use config location URI. Although we cannot point it to a remote location, we can point it to the local file system. So we're going to use the XML to write a JSON. Actually, let's do the meme. We're going to use our XML to write a JSON. We're going to use the JSON to write a jar. And we're going to load the jar through the JVMTI load agent. So simple. This is how a JSON configuration would look in log4j, a valid JSON configuration. We're very much interested in the fact that we have the file name, which is an arbitrary path. This can be a relative or an absolute path in order to overwrite a file. And of course, we have our pattern, which can be a static string. And this will be, again, our UTF encoded payload, because, again, we do not have binary characters in XML. But again, setconfig text only accepts XMLs. So we're going to use the XML. Again, we're going to point it towards a location that we know is writable, either in a Windows environment, C users public, or in Linux temp. We're going to write our mal JSON file. We don't care how the file name is called, but we need the JSON extension, because configuration location URI looks for the extension when determining the content of the file. And of course, we're going to put our data, our JSON configuration, in the pattern itself. So now if we look at the video, we can see a few things that were set up beforehand. We have the file called 00FF, which contains all binary characters from null byte to FF. And we're going to use this log4j arbitrary write pi in order to generate our log configs XML. So this will take the content of 0ff text and it's going to write it on the remote server on the path temp log4j test. So we're going to take all this XML, go to our AMQ instance, go to log4j, go to the operations, which is the exposed mbins for setconfig.txt. It takes two strings. The second string is the type of encoding that will be used, in this case UTF-8. And the first string will be the XML we want to load our malicious configuration that will write our JSON. We go into the Docker because, again, we're testing on localhost right now. And we can see that mal.json has been written successfully on the system. Also, some other files which are X something, we don't care about those. We can see that this is a valid configuration JSON. And in order to actually trigger the writing from the JSON or to load the JSON itself, we're going to use the log configuration URI. We're going to point it file // to temp mal.json. Because again, it looks for the content in the type of the file. Now, if we ls the temp directory, we can see that log4j test has been successfully created. And if we xsd it, we can see that all characters from 0 to ff are written there. So perfect. We have an arbitrary file write with arbitrary content to any location as the CTF user. Now, unfortunately, we have a new problem that arises after this. So after a bit of testing, we can see that our payload may be a bit too long if we encode it too much. So if you know in Apache and also Apache Jetty and Apache HTTPD, the URL has certain size restrictions. In this case, our size restriction is somewhere between 8,100 and 8,200. So if we give it an 8,200, we can see below that we get a request URI too long. The same problem applies for headers. If you give it a too large of a header, it gives you a request header field too large. The only problem is, although our individual payloads are not that big, if you remember, we have our request header URI, which copies the content of the get path. So unfortunately for us, if we put 4,000 A's in the URL and 4,000 B's in a header, we get, again, request is too large because the URL and the header itself is considered one whole part by Apache Jetty. The body of the HTTP request is considered separately. But yes, we need to take that into consideration. So, a small tangent with HTTP 0.1 and 1.1. In 0.1, we could only inject headers. In 1.1, if we do 3 new lines, we can inject a full request entirely and bypass this restriction for size. So, our file, as can be seen in the image, is about 500 bytes long, containing our malicious jar, our JSON, and also our XML. So this is the raw XML payload. We also need to put it in a valid Jolokia request. So it's going to be more than 6,000 characters. If we URL encode all this, because Apache takes into account the URL encoding as being 3 characters instead of 1, we're going to go past the limit of 8,100. We're going to reach about, 6,000 times 3, 18,000 characters. So, again, there are 2 solutions. We can use OA in order to push the irrelevant part of the content into the body of the post, or we can use triple OA in order to make a new request entirely, and we can change the request method to post or do other shenanigans with it. So this is an example. If you fuzzed very well the URL, you can see that the user and the password in HTTP are not put in the URL, but are put in the xreferrer header. So we can do this OA in order to put it in the message body. The other way, which we're going to use for this demonstration, is the AAA, which creates a new post entirely. If we put this in burp, we can see that our first request results in a 302 redirection, but our post request, which was inserted after the 3 new lines, results in a bad request because I forgot to insert the host header. So yeah, my bad. But you can do request splitting, and this is probably one of the ways you can use request smuggling. So this is the idea behind request smuggling. So if we put all this together, we should get the flag. Now let's see how we do this. Again, if we try to call the Jolokia interface directly, we get a 403 forbidden, but we know that the SSRF works. We're going to, again, inject our arbitrary headers. First of all, we're going to send to repeater about 4 times because we're going to need to launch 4 requests on this application in order to exploit it. So we're going to send this to the repeater about 4 times. We're going to go to decoder. We're going to put our console Jolokia list with the authorization and the origin headers, URL encoded, because again, this payload is small enough that it doesn't trigger our request is too long. We're going to get our 200. We're going to look in the list again for the type of the log4j2 mbin, which we needed for performing the following steps of the exploit. We did this beforehand, so we already completed our request. We can see here that we have 3 new lines in the raw form of the body with the new request that was, with the new post request that results after 3 new lines. And if we try to copy this whole payload and URI encoded, we're going to get the, just a second, seems there's a small problem with the video. Okay. Yep, if we, this is the already encoded body, minimal encoding in order to fit in our URL, but you don't need to trust me. We're going to go back to the raw payload. We're going to take it, URL encoded using burp, URL encoded using burp, and then see that the request is too large. And we have a problem. Okay, just a second. Perfect. So we have the request URI is too large. We're going to again go to our pre-encoded payload. Again, minimal encoding, just some key characters. Spaces have been encoded and new lines have been encoded, and also a few other URL key characters. And if we put this request in here, we're not going to get the request URI is too long, but we're going to actually get our the response we're looking for, the 200 response that our setconfig text has been successfully modified with our XML. Okay, now we need to wait a bit for the configuration to be loaded in itself. And from here we can point, as you remember, we can use configuration location URI to point to the JSON from temp. In this case, it's mal JSON from a from the location. Again, the video has paused. I apologize for that. Okay. So yeah, we're gonna take this configuration location URI and point it to our temp, encode it, put it in the URL field, and we can see that we have successfully pointed towards our temp mal JSON. Now again, we need to wait a bit for the configuration to be reloaded. And after the configuration is reloaded, we can use the JVMTI load agent to point to temp mal jar, because our jar has been successfully written. If we get something besides a return code 0, we know that either the jar has not been written or an error has happened in the background. But again, we have tested this locally, we know it works, so this should be just simple. In this case, the jar that executes the following code, it executes chmod in order to make the file readable, and then copies the file towards Artemis plugin in a web root. And we're going to use the SSRF for a final time in order to get the flag. So that seemed very straightforward, not. But anyway, again, doing the recap, we had the SSRF part, which only allows us to do requests locally. We have done local requests to our 8161. We did the CLRF, which resulted in arbitrary request injection. Again, weak credentials. We used setconfig text with an XML in order to write our JSON. We used configuration location URI to point to the JSON and write our jar. And then we loaded the jar with the JVMTI load agent to get remote code execution. And with that, we are done. Christian done to be exact. And that's it. Thankfully, that was all. So I passed a bit fast through the presentation because I'm more interested in your feedback from the CTF in order to discuss points that may have not been very well explained, or other questions or answers or things that you found interesting about this. Or we can also discuss about the log4j presentation from DefCamp Cluj-Napoca because it's relevant. So you have this, well, you don't have the stage, but you can raise your hand to get a microphone and ask questions. Or you can pelt tomatoes at me because, yeah. So, okay.
Thank you. Okay. So first of all, thank you for your presentation. It was awesome. Based on your experience, you said you have almost 9 years of hacking experience. How often do you go through rabbit holes, and how do you deal with them?
All the time. Usually, my skull is thick enough that I can just go through a rabbit hole and find a vulnerability at the other end. So, yeah. But usually, I have spent more than my fair share of time going into rabbit hole, and at least I consider them a learning experience if I don't find something that is actually relevant. But most of the rabbit holes, I consider them, besides a learning experience, an occasion to take pieces of the puzzle, because a remote code execution, as you've seen here, is taking multiple parts and chaining them together in a remote code execution or in an actual working exploit. You don't need to have a Picasso type painting out of your puzzle pieces, but as long as you reach your end goal, it's good. They don't need to fit, they just need to be, to resemble a solution. So yeah.
And how much time do you think is too much time for a rabbit hole?
Well, it depends. If you have a time-based engagement, which is just, let's say, 2 weeks, you can probably spend at most 1 day, let's say 2 days on things that may seem interesting. You should do your fair share of enumeration beforehand and then select from that enumeration a few vectors that may seem juicy. And from those, you can spend 1 or 2 days. If you actually manage to do something more interesting than you initially thought, you can stay and dig there a bit more. But you need to also do your due diligence and pass through all the steps of a pen test required to say that you did the testing and you did not waste all your time on the rabbit hole itself.
Thank you.
If you have more free time and you do it for yourself, then you can, I don't know, I think I stood months on a rabbit hole at some point in time. And again, the rabbit hole actually was something interesting. Okay, next question.
Hello, thanks for the presentation. One quick question. What, from a defender perspective, what needs to be patched for this to not work? Is there like, I think there was a log4j vulnerability that you mentioned.
So interesting enough, log4j does not consider this to be a vulnerability. But thankfully for you, Apache Artemis MQ, Red Hat AMQ, and Apache ActiveMQ have patched these vulnerabilities. So if you take the latest version, then you should not have problem with these. If you're still using an old version, then yeah, you should switch to a newer version, unfortunately.
Okay, and from, I guess it's related to the time spent question from before, is how would you compare this to the regular vulnerabilities that you find in, because as you explained, this chains multiple attack vectors and techniques and things like that. Is this something typical that you find in real world applications, or it is, well, I mean, these are real world applications, but I mean, like a real attacker will probably not go to this depth and length to...
And the SSRF was added because I was curious about it. This should, the application in theory only listens on local hosts. So the SSRF or let's say HTTP request smuggling would be required in order to access the URI. So in a real life scenario, this may actually happen. But this is the theoretical part, the SSRF. The actual part of restrictions and ActiveMQ exploitation was, how should I say, it happened during a client engagement. So 0 Deus 3 is because of a client engagement with the restriction that I could not override the VARs, the broker XML file parsed something strange and I could replace it, but I didn't get remote code execution through it. So this jar vector with no outbound TCP connection was exactly a client environment. So yeah, it's a real world attack.
Okay, thank you.
Hi, in your presentation, server-side request forgery, the payload was sent from internet to an internal asset or was sent from internal network?
It was in the internal network due to the restrictions with the Docker environment. It was put on the same server as the log4j, as the ActiveMQ application, actually AMQ application. So yes, we had an Apache HTTP server that hosted a PHP, which happened to be on the same server as our AMQ application. So yeah, in theory, you had access to the Apache server through the internet, and through there you could find that it does SSRF requests to local resources, which are in this case the AMQ vulnerable application. Any other questions? Okay, if there are no more questions, you can probably find me outside for feedback. And again, if you find the colleague that is selling tomatoes, you can still throw them at me for the following minute, which I'm on stage. Thanks again for participating, and thank you for the questions.